All right, good evening, good afternoon, and welcome. So I want to make sure you guys understand this is the review for the Chapter 7 test part 1. Okay, so if you haven't taken this test yet, which hopefully you haven't, use this video to kind of help you walk through the guide of how to do it. Have Alex open, okay, and on your review to make sure you guys can go through this process. Try questions multiple times as well throughout this whole example because there are different versions of this, okay? Because I'll show you one thing that might be different than yours. And then you guys need to make sure you can do yours as I show you mine and kind of see the different caveats of how things work. Okay, so first and foremost, one of the big things I want to make sure you guys do is understand that I am going to be using Desmos to show some of you this, but I will also show you how to do it by hand as well. Okay, so number one on the board here, g of x is 6 of x. Fill out this table here. So basically in Desmos, I'd come in here and I would put in 6 of x. Simple as that. Remember we talked about you can hit the edit list button here and create a table. Now, one key thing I want to make sure you guys know is on number 1 here, you cannot enter a decimal. It asks for a fraction no matter what. So what I want you guys to do is use kind of just an evaluation system of understanding 2 is 36, 1 is 6, so on and so forth. And so what I want to make sure you guys know is that 6 squared would be 36, 1 squared is 6. But what happens when you have a 6 to the negative 1? Okay, we had talked about this before in our class that a negative exponent you can't actually have, and that technically this is 6 over negative 1, and so what you're supposed to do is flip it, that this goes to the bottom. So this would be 1/6. So that is the fraction equivalent to what that decimal is that you see in Desmos. Okay, and then same applies if you have 6 to the negative 2 power, all right, it would be over 1. And then you can't have a negative exponent, so to get rid of it, you flip it down to the bottom. So you bring the 1 up, the 6 down, which would be 6 squared, or 1 over 36. So that's your answer for that example there. If you're a fraction, so say for example you started and your f of x was here, it was 1 to the 6th of x, like this, which I've had almost all day today until I kind of did a refresh on this. One aspect is no, it's the same principle applies, but backwards. And what I mean by that is 6 is negative 2 ends up being 1 over 36. But if I go 1/6 to the negative 2 power like this, what actually happens is the negative 2 exponent gets tacked down here. So it'd be 1 to the negative 2 over 6 to the negative 2, and would actually flip it back up. Okay, so it'd be 32 over 1 or 32. So know if you're a fraction, okay, you're going to actually flip it back up. And you'll notice when you go in Desmos and you graph it, that you'll see the negative 2 exponents. So instead of it being like we are here, where negative 2 is the decimal, it'll actually say negative 2 is 36, negative 1 is 6, and then it'll always say 0, 1. And then these will be the decimal points. So you guys know 1 would be 1/6, and 2 would be 1 over 36, okay? So know that if you have a fraction, what I'm showing you, things will flip, okay? Hopefully you guys understand that setup, and then we'll go from there and get rid of that. All right, next, number 2, same style, okay? Graph it. Now on this one here, if it's f of x, you would do the same thing, 4 to the x power, use the gear, convert it to a table, bam, there's your, or you could use the fractions, okay, where it would be, you can put the values in. You can put decimals in here. Make sure you use the whole decimal if you do it. Okay, and what I mean by that is these stop, but sometimes you might have a repeater that comes out 333. Put in as many as you can, like 4. Put in like 6 or 7 3s. So if x was a coordinate here, make sure you guys know you put the coordinates in like this. All right, so I know one of them is 0, 1. So I know if I put a 0 and a 1 here, so I would go 0. And then 1, and here's one trick for you guys, is when I type in the number 1 right here, you can see the point appeared. Now make sure you still plot it, but know you're looking for 5 points. So if your thing doesn't say you're missing a point, check your values here to make sure you have it. So that you'll have one at negative 1, that you'll have one at negative 2. Make sure if you plot one like this and it says you don't have 5 points, check your points. Because you can see, oh, I'm missing the one at 1. Or maybe you went like this, okay? Or let me back that one up a little bit. I did see one student earlier today she plotted a point like this, and then it was 2 points like that. And when it graphed it, it went whoop, like something like that. And the problem was that she had too many points on the number 2. She made a mistake. Check your numbers and make sure she put x the same value. She put x as 2 twice. Don't do that, okay? Make sure you guys check the figures and numbers and you go from there. Graph it. I'm not going to do this one. You guys can figure it out. 3, exponential functions, okay? It's going to talk about what is the range and domain. The domain is the x values. For my class, I always talk about the wrestlers. There's a faction a long time ago called D Generation X. So dx. It's dx and ry, okay? So the domain is the x values of going left to right. It's never going to stop. So it's going to be all real numbers. So my domain is going to be all real numbers. It always is. Now, you'll get partial credit if at least you get that. Every time you see domain, it's all real numbers from going left to right. This graph never stops. Vertically speaking, though, we have an asymptote, okay? So what happens is we have an asymptote at -4. So we know that this graph goes down to -4 and it doesn't actually stop. Now here's my issue. Everybody's like, which way does it go? All right, what you need to do is on the y-coordinate, this is shooting up in the air, is pick a value of y that is a legitimate point. So what I mean by that is I don't see anything that crosses, okay? So what I mean by that is I can go up. So if I'm at the x value and I go over 0, so if I go over, I don't know, that's almost 5. It's like 4.8. But what is my y value? It's 0. What is my y value here? 1. What is my y value here? 2. What is my y value here? 3. What I'm trying to get is make sure you guys understand I want some type of y value. So I'll go 3, okay, just because that's a part of the line. And then you tell me which one would you eat, which one is bigger. And it's that, okay? That one is bigger. So let me back that up, do it one more time. What value is 3 bigger than -4? Yes, remember you eat the bigger number. So if you're going this way, you would go that way again, and that's your answer. So your range down here would be y. So let me do, am I on the range? Yep. So I'd go y, and then I would go greater than, or is greater than, and then you would just type in -4. Right? Typed in -4, hit my check, and I'm correct. Okay, do that answer to make sure. Okay, now 4, same thing, but it's going down. Mine is going down. Yours, you could have 2 going up. Make sure you guys check the same thing. Okay, range, domain is going to be all real numbers. We know that, simple enough. Range, same thing. Okay, -1 and a y. I know -1 because the dotted horizontal asymptote is going at -1. And then you tell me what is a legitimate point. As you're looking on this, a legitimate point would be y is -6. I actually have an intersection here at 0, -5. So I could use -5 here and -1. And then you tell me which one is bigger. Well, it would be the -1. So on my answer, I'd go y is less than -1. Okay, so let me do that again. I have to, otherwise it's going to tell me to enter an answer, or I have to delete the all real numbers. So I'll go this, -1. I check it, and it should be correct, and yay, it is. Okay, 5. 5, ladies and gentlemen, is a simple graph. Now, one thing I want to make sure you guys know about this is some of you are going to struggle with this this concept. Okay. Make sure you check your notes when we did about transformations, which was lesson 7.6. I don't have that video on YouTube. I don't think I do. But what it basically meant was it was x minus h, okay? So if it's x minus h and this value gets put in, what I want you guys to do is understand, and hopefully you're able to do this, is understand how things shift, okay? And what I mean by that is here is my x to the 4th, okay? Where did my mouse go? There it is. All right, 1/4 to the x. This is the same thing, okay? So if I turn it off, you see the line turn different colors. It's the same thing, but here's the key. When you set this up in decimals, you have to put a plus with the brackets around it. You see the difference. Now, mine is -2. So when I take this up here and I put my cursor up here and I go minus, and then I put the number 2, watch the graph. It's going to shift to the right, 2. Okay, I'm looking at this y-intercept. It's actually going, now my graph is zoomed out a little bit. So this is 1, 2, 3, 4. And if you guys notice, it's going 1, 2 over to the right. So what you would do is go into Alex, grab the line and go 1, see the blue dot, the blue little X, I go over 1 and 2. So there I'm over 2. Now it's minus 3 in decimals. If I go minus 3 on this back end here like this, minus 3, I notice my graph goes here, and it goes which way? It goes down. But how much does it go down? Same thing. You can look at this line here now. This is 1, 2, 3. It's down 3. So now what you do is you go back to Alex, and you would drop this bad boy here, this point, 1, 2, 3, and that's it. All right, check your answer. Yes, of course I get it correct. All right, try the shifting out. Try another if you want to, okay? Make sure you guys know that this is plus. Now if it's plus, it doesn't actually go to the plus side 3, it actually goes left because it's supposed to be x minus. And it's x minus, but in order to make it a positive 3, that's actually negative 3. So it's actually going to go over 3 to the left, and then it's going to go up 1. And if I check my answer there, A, I get that right too. Okay, so understand that concept, that minuses are actually going to the right and then down on this part. And then on this, ladies and gentlemen, if this is a plus sign, it's going left, however many coordinates, and then it's going to go up, of course, if it's a plus. Okay, hopefully you guys see that, and I'm focusing mainly on the intersection part and moving it. Okay, 6 is a tricky one. I showed you guys in class how to do this by hand. I want you to do it by hand here again, and this is what you're shooting for. Y equals AB to the X. Okay, this is an exponential function. Please make sure you guys set it up like this, okay? So we don't know anything. I don't care about this first point, nor do I care about the last. I care about the 2 in the middle. We don't know what A and B are, so we're trying to solve for A and B. So what we have here, though, is we want to go, so we're going to go A equals something, and eventually we're going to go B equals something. So what we're shooting for is understanding plugging in a value. Start with the 0. So Y is 10. So this would be 10 equals, we don't know what AB is. And then my X value is 0. So if I plug a 0 in here, ladies and gentlemen, anything to the 0 power is 1. So what happens? This actually cancels out, and it becomes 10 equals A times 1, or A equals 10. Okay, so here my A value is going to end up being 10. All right, so now, or you guys can know if you ever see it in a block like this, that this is going to be A, all right, because of the intersection. Next would be finding the other point. Okay, so once again, we're going to plug in the values. So I'm going to plug in a Y, or my Y is 50. So I'm going to redo this again with 50 equals, we know our A now is 10. We don't know what B is, but our X value is 1. Okay, if X is 1. Now, ladies and gentlemen, you can rewrite it, because do we really write B to the first power? No, we don't. Just go 50 equals 10B. And then this, ladies and gentlemen, we've been doing since August and July when we first came into school. Divide both sides by 10. B equals what? 5. Okay, simple enough. Then over here, you have your value of 5. Now, can you give me your equation? Yes, you can. So the answer ends up being Y equals 10, and then how you would enter it here, it would be times 5 to the X power. All right, that is what would go here. And then, ladies and gentlemen, you get the right answer. Try your own. Pause the video, back it up a couple times, refresh it, whatever you need to do. You guys I know will be successful at it. All right, the next one here is understanding the setup on number 8. Okay, when you're going through the process. Where did I lost my mouse again? Stupid mouse. Hold on, everybody. Oh, there it is. All right, go on there. That was number 6. Number 7. Okay. Now, when you're going through this, I want to make sure you guys understand. You will see very different variations of this on the test compared to what I'm about to show you. Okay. Find the initial value of the car. It's always this value here, which is A. So I would type in this. Then it does this function represent growth or decay? Every formula, I'm going to have them written up. Okay, the formulas are Y equals A, and then it's 1 plus R to the T, and it's Y equals A, 1 minus R to the T. This is growth, that's decay. What's the key number we're looking at here? It's the 1s, okay? So if you have the number 1 and you're going up, that would be growth. So if it's any number greater than 1, if it's any number less than 1, that would be decay. So if you're looking at this right here, what is this? Is that number greater than 1? It is. So that would be growth, okay? Now, previous examples all day, I've had like 0.88, okay? If this was not this number here, but was 0.88, it would be decay, okay? Just understand that concept. But right now, this is growth, okay? So this is growth. Now, what percent is the value? So it's easy with growth because all you have to do is, remember, it's 1 plus the rate. So if you get rid of the 1 here, you can see what blocking my hand with the 1 is 0.16. So if you have 0.16, you change this into a decimal because that's what it's asking, a percentage, and this is what? 16%. You take it from, a decimal to a percentage, right? So you're 16. So down here, the percentage would be 16%. The same is true if you go the opposite direction, and I'll show you that with an example we have later on. When we did, or I'll show you now another version of that. If, for example, you have something like 0.88, okay, and it was less than 1, what you guys would need to know is that it's 1 minus. So you go 1 minus 0.88, and that will actually, you go backwards to get the rate, okay? So if I plug this in, it would be 0.12. If I put that in a calculator, and then 0.12, you can convert, moving the decimal to the right to get the percentage of 12%, okay? Understand how growth and decay works. It's very important. This will probably be on the midterm. I know it will. We're going to create a midterm this year. I thought we might have a Galileo district one, but I found out we're not. So in class, we'll be creating a big fat midterm for you guys, and it should be a lot of fun and slightly aggravating. 8. Now you got to write the equations. Key thing you need to know about is, ladies and gentlemen, the word. So let me actually back this up and I'll erase it. Okay, make sure you guys understand when you read this problem, it talks about decay. This one is decay. So my decay formula, again, is y equals a, and then it's 1 minus r to the t. Okay, so same thing applies. What is my a value? It's going to be 500. So it's going to be y equals. You actually have to put this formula that I'm about to write just like that in here because it's between the relationship of y and t. So y, and then it talks about there's a decay. So if it's decay, it's 1 minus the rate. Okay, remember, my rate is 6.6%. How do you change that into a decimal? Instead of like we did earlier, where we moved the decimal to the right, you actually move this decimal point to the left 2 spots, plug in a 0, so it'd be 1 minus 0.066 to the t. Now guess what? You can enter this equation into here and get it right. You do not have to simplify it. If you want to simplify it, you can. It's up to you, but just enter it like that, and you guys will get the right answer. Okay, I've already tested it twice today. Make sure it works. I can test it again if you want, just to make sure I'm not lying to everybody. So it's going to be y equals 500, and then it's going to be this bracket 1 minus 0.066 to the power of t. And check it. And yay, your answer is correct. However, it's customary, blah, 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 blah. Who cares? Okay? I don't care. There's the alternate answer. Whoopie freaking do. Okay? I got it right, so who cares? Okay? Enter it in. You guys will get it right. All right, number 9. Put this in the calculator. Who cares? Initial value is 27,500. And then the value after 12, you put the number 12 in here, ladies and gentlemen, and give me the answer using a calculator. Final. Number 10, okay, so I want to make sure you guys understand this is the compound interest formula. It is A equals P, and then it's 1 plus R over N, N to the T. A lot of students today were missing a couple things, and sorry my ends look weird with this pixelated pen. Okay, one thing I got to make sure you guys understand is what is the P? P stands for the initial value, which is that number. R is interest. We're looking for PRN, the interest rate. Okay, this would convert to, this is my R, which equals 0.034. And then the last key piece is compounded quarterly. N equals how many times something is compounded in a year. Quarterly is 4. Okay, so no, this would be 4. If this says semi-annual, so hold on, let me back that up. If it says semi-annual, and I spelled that way wrong, it's 2 N's, that is N equals 2. All right, if it's annual, which I don't think any one will be, N is 1. And if it's monthly, it is going to be 12. And that was a word, there you go, that's better. That's 12. So N would be 2 if it says semi-annual, it says quarterly, N is 4. If nothing is made, how much is in the account? A, oh, that was bad, A. A equals P, 4,000. And then it's going to be 1 plus my rate, okay? If you know what your rate is, again, that's why I have you guys do all of this before you fill this out. And then it's over my N value, which is 4. And then it's times, and this is where I've seen multiple mistakes today, N again to the letter T, time. There is your formula. In the calculator, you want to make sure you enter it out. And then instead of entering T for here, it would be 5. So I would scratch out the T and put times 5 or 20. Okay, so I could rewrite this as A equals 4,000, 1 plus 0.0344 to the 20. Now, what I will do is I will make sure you guys put this in, and it says enter it, round, do not round it, and put it to the nearest cent. I have seen twice today where my students have put this number completely into a calculator and they get it wrong, okay? So what I want to make sure you guys do is when you figure out this calculation, maybe you should do this little calculation first, combine these together in a calculator, all right? And then, ladies and gentlemen, you would have A equals 4,000, and then it would be whatever that number is. So like, for example, let me look here. If I go on my calculator, it'd be 0.034 divided by 4 is 0.0085. So what I mean by that is in my calculator, I would go A equals 4,000, and then it would be 1.0085 to the 20 power. Sorry, I'm getting everything squagged. I can only go down so far. If I go to the 20 power on there and I put this into a calculator, I will actually get, so 4,000, and then I put a bracket around it, 1.0085, and then that would be to the 20 power. If I hit enter, I actually come up with 4737.81. So I want to actually see if this works. I have seen today a couple different students come up to me and be like, hey, I put in an answer that is close, but it's marking it wrong, okay? The problem is that it could be a rounding issue. So let me check on this one. Come on, where'd the mouse go? I lost it again. Oh, there it is. Let me hit check. All right, I got it correct. I have seen it today, guys, where the answer is on a calculator come out to be 0.3, but for some reason Alex wants it as 0.25. It actually is a quarter. So show your work on this one especially. So that way if you do get it wrong and you guys do your report at the end of the test and you see that rounding issue, you can come up to myself, Miss Q, or Mr. Parsons, whoever's watching this video, and say, hey, I did the math right, but it didn't round correctly. Okay, so check that. That's it for this. Do your best. This is part 1. I know you guys will blow this test away. I'm hoping all of you do because it's a big test. And then if you have any questions or concerns, see me in the morning before the test or before you do take it, whenever you get a chance to, because I know I have a lot of people out on Friday. Good luck. I know you'll do great, and I'll see you guys soon.